First of all, I talked to Miss Gupta about this, and she said most of this is not necessary for calc. One, some of it you need to have seen before when they teach this in further calc if you're going to be, engineering or math major and you got to take more calc. But part two of that sentence is Hofbauer messed up like how many days we needed to finish this chapter. So then I went back and said, okay, this isn't on the final, this isn't on the final, this isn't on the final. So I shortened the quiz and took some stuff off. So there's some stuff we're going to cross out today and some stuff we're just going to kind of introduce and use the reference sheets for. The next quiz on Tuesday is almost all multiple choice, and you get to use all those reference sheets that you want there, the pink, the blue, and the tan, okay? Deal? All right, so I'm going to kind of give you a little rough overview of some things. Today's lesson talks about converting between polars and rectangular coordinates. That sounds, I don't know, does it sound easy or hard? I don't know. But when we plot a point like this right here, what did we call that starting back in, I don't know, 5th, 6th grade? What was the name of that point right there? Okay, a y-intercept or just its ordered pair was 0, 3, and that was an x and a y, right guys? Okay, we recently learned that if we did some junk like this, that same spot right there, 3 up, would have been called what? If we were in degrees, 390 degrees, and we learned it could have a whole bunch of names, right? Unfortunately, today they're going to do a lot of stuff in radians, and they're going to do some stuff in decimals, which is kind of painful. But right now, we know this is an r and a theta, okay? I need you to tell me some relationships between those. Do you remember anything that had an r and a theta and an x? X equals r cosine theta. Does that sound familiar? Y equals, okay. There was another one, x squared plus y squared equals r squared. And then the inverse tangent of y over x equals theta. Do those all look familiar? Okay. The reason guys, those are the ways you switch back and forth. And the reason they look so familiar is because I used the same notation when I taught vectors to you. Remember the book used a little bit different notation? They used like the magnitude of v cosine theta and stuff. And I just called it r cosine theta. That's because I knew we were going to need it for now. So why not just call it the same thing both times? That make sense? Okay. So all of today is just using those to go back and forth. So if we know r and theta, we can use this to find x and y. Does that make sense? If we know x and y, we can use this to find r and this to find theta. That's it. That's the relationship between. The trouble comes with this booger. Remember, when you do this on your calculator, you don't always get the right answer because it always finds only a quadrant 1 or 4 answer. So we have to fiddle with that. The other thing is they painfully ask us sometimes when we're finding r and theta. Remember how the r theta system, there's more than one name for a point? They ask us to find more than one name. Okay? So here we go. The first part is not complicated at all. All this is in your notes. Okay? The first one says, given this, find the rectangular. What does that mean I'm looking for when it says rectangular? X and y. That's supposed to be a comma. That's a weird comma. Okay. So this is an r and this is a theta. What's the relationship we just talked about? To find x, you're going to do, okay. And to find y, you're going to do, that's it. Now, 3 pi over 4 happens to have magical properties. It's on our unit circle, right? So rather than just typing it in, they did exact. Can you look at your unit circle and find the cosine at 3 pi over 4? 3 pi over 4 out 3 units. The ordered pair on your unit circle, negative square root of 2 over 2 and positive square root of 2 over 2. So if I put those values in here, what was R again? R was 3. So if I replace that with a 3, 3 times negative square root of 2 over 2 would just be negative 3 square root of 2 over 2. And 3 times positive square root of 2 over 2 sounds a lot like 3 square root of 2 over 2. That seem okay? Nothing tricky there. Okay, so let's try this. Is negative 60 something that you have on your unit circle? Okay. Negative 60 is the same as 300, so what's the ordered pair there? Everybody agreeing with that? Okay, so R is 20. The cosine is 1/2. The sine is negative square root of 3 over 2. Yes? Got that off the unit circle? So X is going to be R cosine theta. And Y is going to be R sine theta, which will become what? Ordered pair. Do you remember that little thing some of you did yesterday all day called the SAT? Okay. This said if I went negative 60 degrees this way and I went out 20 units, and we're supposed to be finding this X and this Y. There were 30, 60, 90 triangles in like 3 places yesterday on the test. Not that I looked at any of the questions and not that we're discussing the test, okay? But the relationship here is half the hypotenuse is the short leg, which would make this 10, and this is the short leg times the square root of 3, and it's going down. Did we come up with that answer? Okay. Number 2. Now, this seems kind of weird that R can be negative, but remember how that works? It means we went 5 pi over 6, but then we backed up 1, and we were down in this quadrant. The good news is we really don't have to mess with that. You can still use X equals R cosine theta and Y equals R sine theta, and you can just use the negative. So at 5 pi over 6 on your unit circle, the ordered pair is negative square root of 3 over 2 and 1/2. Could I write that any smaller? Sorry. So if R is negative 1, we have negative 1 times negative square root of 3 over 2 and negative 1 times 1/2. So we get positive square root of 3 over 2 and negative 1/2. Did it take care of itself and give us a quadrant 4 number where we knew we needed to be? Yes, right? Square root of 3 over 2, 1/2. We good? Yes, you could have changed this to positive 1 and 11 pi over 6 and it would have done the same thing. Jacob, you okay? What this said? That's just the ordered pair at 5 pi over 6. Do you have your unit circle? So you know where I'm getting that? Okay. Sorry, it was really scribbledy and messy, and that little button isn't working for me today. Okay, can you guys try these two? Remember, you don't have to do anything crazy. They are both on the unit circle. So go to negative 135 when R is 6. Use your ordered pair. Tell me what the XY coordinates are going to be. Did I get the ordered pairs right? Anybody checking me? So when I multiply by r, this becomes what? And over here, when I multiply the r of 3 by the x and the y, again, it's x equals r cosine theta. So that becomes 3 times 1/2. Everybody knows where I'm getting this, right? I'm not, okay. Y equals r sine theta, which is 3 times square root of 3 over 2, which doesn't simplify. We all good? What if it wasn't a unit circle number? Then we'd be super excited because we'd just get to type it in, right? If it said radius of 7 and an angle of 28 degrees, you'd type 7 cosine of 28, 7 sine of 28, making sure you were in the 28 was degrees, right? All right, moving on. We got to go the other direction. Remember a minute ago we talked about, where are they? These 4 things, yes? Have we used all 4 of these yet? Guess what? We got to use the other 2 now, okay? We're going backwards. We're trying to figure out what the r and the theta are. So let's think about this for a second. If I told you to go over 5 to the right and down 9, could you find r? Does it make sense that you just use Pythagorean theorem? Okay, so r squared equals 5 squared plus negative 9 squared, and you'd get square root of, I think, 106, yes? Okay. Now, how would we find this angle in here? Yep. Tangent, inverse tangent, y over x, or opposite over adjacent, so negative 9 over 5. Now, can we just do this in degrees and then worry about the radians in a second? Because it's really hard for me to explain the radian business, and I'll show you why. Put your calculator in degrees. Do inverse tangent of negative 9 over 5. Whoa. I forgot the inverse and got a really weird answer. Anybody get about negative 61? I'm just going to call it negative 61 degrees. Is that okay? All right. Now, is negative 61 in the right quadrant? Negative 61 is in the correct quadrant, right? Okay. The problem is, first of all, they want radians, but the most important problem at the moment is the directions on the next section say you got to, we're going to do it in radians, but for now, degrees, you'd have to answer between 0 and 360. So we need to rename that guy. How can we rename that a positive way? Add 360 and we get what? Okay. So an exact answer with degrees, well, exact as in the square root of 106. It's not exact. And 299 would be 1. Could you give me another one? Like the angle still has to be between 0 and 360, but the r doesn't have to be positive. So how would we go this way? Take that negative 61 and do what? Add 180. If we took negative 61 and we added 180, we'd get 119. But if you went only 119, you'd have to do what? Back up 106. All right. So we found 2 answers between 0 and 360, one with a positive r, one with a negative r. Okay, this is the miserable part, guys. They want it in radians. Okay, so put your calculator in radians and do the same thing. Do inverse tangent of negative 9 over 5, which you can just go switch the mode and then hit enter if that's the last thing you did. I got negative 1.06, yes? Okay. So one pair is negative 1.06 they have here. And where did they get this 10.3? Yeah, they took the square root. Since they were answering in decimals anyway, they took the square root. Now, how can we find another name for that? We could add 1 pi, right? Because we added 180 down here. We could add 1 pi. So negative 1.06. Okay, 2.1-ish. 2.08, I don't know. And if we do that, what did we have to do to the r? Negative. Now the problem is on the next section, they say that second answer wouldn't have even, the first answer they gave us wouldn't have even worked, because look what the directions say. The first answer we got had negative 1.03. That doesn't fall between 0 and 2 pi. Okay, I'm not liking these questions, but I will tell you this. Remember, the quiz is multiple choice, okay? So the first thing you would do is make sure your choice is in the right quadrant, okay? And if it gives you exact answers and you get a decimal, you know how to fix that, right? Type them in. Type the choices in. If it gives you, you get an exact answer and the choices are decimals, type your answer in. Okay. Here we go. This one, I'm hoping some of you can do without a calculator. Over 2, down 2. Okay. I heard a 45. Why did I hear a 45? It's an isosceles right triangle, yes. So everybody knows it's a 45, 45, 90. Okay. So in degrees, we could have said this angle's negative 45. I don't want degrees, stupid people. Okay. So what is negative 45? Negative pi over 4. Can we answer negative pi over 4? It's not between 0 and 2 pi. Can you look at your unit circle? What is the name of that spot right there? 7 pi over 4. They'll let us get away with that. Okay. We need the r, though. Some of you can do it because you know your special right triangles. Some of you still got to do Pythagorean theorem. You get the same answer either way. Square that, square that. 4 and 4 is 8. Square root of 8 is 2 square roots of 2. Okay, there's an exact answer. Decimal for either one of those would be fine. But we need another because it says 2 pair. How about if we go straight across the triangle? Look on your unit circle. 3 pi over 4. But if you went there, you did what? You backed up square root of 8 or 2 square roots of 2. Nice job. Now, if you did all that on your calculator, you would have got decimals, right? When you typed inverse tangent negative 2 divided by 2, you would have got negative, and it's an ugly decimal because it's equivalent to pi over 4. And then you would add 2 pi to get a positive answer. All right. Let's try this one. This one is not a unit circle question at all, right? What quadrant are we in? 3, 5. I wish it was 3, 4, 5, but it ain't, because this is the hypotenuse. 3 squared plus 5 squared, 9 and 25 square root of 34. Okay, we're going to do 2 answers. Okay, what are we going to do for the first one? Inverse tangent of 5 over 3. What mode do they want us in? Radians, because it said between 0 and 2 pi. Inverse tangent 5 divided by 3, making sure I am in radians. 1.03, anybody? Okay. We need another answer, and that's in the correct quadrant, yes? Okay. We need another answer that says I went all the way around here and then I backed up the square root of 34. How do we get one straight across from there? In radians. Add a pi. 4.17, anybody? Okay. I'm pretty sure the one on the quiz, I know it's multiple choice, and I think it's even a special right angle, so you can use your unit circle. But either way, all it is inverse tangent and Pythagorean theorem. What's wrong? You sure? Okay. Now, this is the stuff that I'm cutting out, and let me show you why. This is a circle of radius 4. Everybody good? Okay. This is the same circle of radius 4 in polars. Remember we graphed some stuff like this, right? We went on our calculator and we graphed r equals h cosine theta, and it came up with a circle. The reason it's so messy is because you have to replace x with r cosine theta, y with r sine theta, square this disaster up here, which is like multiplying all that out. You move some stuff around, you factor it out so that you get a cosine squared plus a sine squared is 1. You divide off an r on each side to get down to this. Okay? Are any of us going to remember that the rest of our lives? No. So we're just going to skip that whole section. So the next question I want us to talk about is all the way down at number 15. I want to give you a couple minutes to look at number 15 and figure out which choice. It is choices, so think carefully. How many of you are feeling really confident you got this? Basma's the only one? Monica says she got H, but she's not super confident. What do you have to do? Okay. You have to find R, just Pythagorean theorem, right? Okay. And as soon as you got that it's some icky decimal or it's equivalent to 3 squared to 2, then who said you just figure out which quadrant it's in, right? Either pi over 4 or 5 pi over 4, which one puts you into the right quadrant? Okay. If you did it on your calculator and you did inverse tangent of -3 over -3, you got an ugly decimal, right? And if you typed it in, it would have been equivalent to F. But that's not in the right quadrant for us to be at negative. So you would have had to add pi to that answer and then type it in. All right. Process of elimination is a better choice on that one. Okay, what about number 16? What are they giving us? Yeah, polar, an r and a theta. How do you get an x and a y out of that? That's your favorite kind, remember? Yes, 4 cosine of 150, 4 sine of 150. And you could do it on your calculator, but you'd have to type all these choices in to figure out which one's right. What quadrant are we in? That might help. 150 is quadrant 2, so it should be a negative positive. Okay. Then I just got to figure out, like, what was the ordered pair at 150? So A is a good choice. Or it's equivalent. If you typed it in, you've been on your calculator. What mode did your calculator have to be in, first of all? Degrees for that one. But if you typed 4 sine of 150, I hope you got a positive 2. So that would work with that one. Okay. 17, you can skip, but let me just talk you through this one because it's a super easy one. X squared plus y squared equals r squared. That sound familiar? And y is equal to r sine theta, yes? So then you would divide an R off each side and get this choice. Okay. But that's not on the, that's the part I'm telling you you don't have to do. All right. This will be your favorite part of the whole day. Gone. Okay. Okay. Do those though. Do the ones that are assigned, because you got to know how to go back and forth. And I think especially the going from polar to XY is tricky. Now, I'm going on to the next lesson. So you might have to watch the second half of this. I guess I could start a fresh video. You want me to do that? I'm going to go on and talk about 9.4 now, okay?